Hello, everyone. Am I understandable also in the back? Yes? Okay. Okay, let's get started. My name is Arjen Hoekstra. I'm a developer for Mendix for almost 10 years now. And currently I'm part of the Mendix Runtime team. And the Runtime is the part of the platform which actually executes the models, which are created with the Mendix Business Modeler. Today I will give this presentation together with Kilian, and he will introduce himself now.
So let's see if my microphone also works. Well, I guess it does. As you can read, my name is Kilian Kruse. I'm working for Conclusion currently. I'm a Mendix MVP and have been developing Mendix applications for roughly 5 years now. And in that time, I've developed applications on my own in a matter of weeks, up till apps that we've developed with multiple Scrum teams that ran for a few years. So I've seen quite a lot of applications in the last few years. And I was very interested in this subject, and that's why, together with Arjen, I'm here today to talk to you about high availability and scalability.
Okay, thank you. Well, in the next 40 minutes, we will tell you all about what high availability and what scalability exactly entails, and why this is so important for your Mendix application. Before we do that, let's first start with a short quiz. Does anyone know who this is? Close. Anyone? Lady Gaga, indeed, this is Lady Gaga. And we also know what she has to do with Amazon.
The songs get downloaded from it, or they posted it.
That's true, it's close. In May, let's see if we get there, yeah, May 2011, Amazon did a big promotion. They offered Lady Gaga a new album for only $1. And a lot of people went ahead and bought this album, around 500,000 actually. But that was a bit too much for Amazon servers, and they collapsed. And some say that this might have been a happy crash for Amazon, because they paid the full wholesale price of $8 to Universal. So that means that they lost around $7 per album they sold. And so this means this is around 3.5 million. And you can imagine if the servers would have been up, that would be way, way more. The next one.
So next question, a very easy one. What's that? A squirrel, there we go. So what does a squirrel has to do with Yahoo? They're not sold on Yahoo. At least I don't hope so. Yeah. Yeah, there you go, in the next slide in 2010. Sorry for this slide, guys. But actually a squirrel ate through an electric cable and took down half of one of Yahoo's data centers.
Okay, the final one. Who is this lady? Ellen DeGeneres, indeed. She's a famous US talk show host. And what has she to do with Twitter? She tweets a lot.
Almost. Yeah,
indeed,
there
very
you go.
good, very good. In March 2014, Ellen posted a selfie with a lot of famous actors during the Oscars. And in 1 hour, this got 1,300,000 retweets. And that was a bit too much for the servers of Twitter, and they collapsed. And up to now, this is still the #1 tweet. So that's nice to know. So we saw a couple of big companies, and they were all not capable of optimally serving their customers. Yeah, of course, that's not nice if you're, as a customer, if you're not served optimally. But why does this matter? Why is this so important? Because if you're only a few hours not looking to your tweets, you could say, okay, does that really matter? Let me give you one more very recent example. Last month, on the 10th of May, Salesforce, which is a big software company, had a significant outage, which led to the NA14 instance to be down for almost a full day. And this had some consequences. The first one is that actually in this case there was data loss. 4 hours of data got lost for some of the customers. Secondly, this of course has financial loss, both for Salesforce and also for their customers. And third, this can also damage the company image. As you see in the next slide, the CEO, Mark Benioff, took Twitter to apologize for this, to repair the company image. So imagine you have your application and it's running really well and it attracts more and more visitors, so more and more load is generated. You definitely want to avoid these kind of consequences. And this is where high availability and scalability come into play. And Kilian will tell you more about this now.
So yeah, a short agenda what we're going to talk about today. We'll first start with a bit of theory, so that we're all on the same page, that we all have a common understanding what we mean when we talk about high availability and scalability. We'll do that together. After that, roughly 15 minutes into the presentation, I will give a short demo, also of about 15 minutes, how you can deploy an application, a Mendix application, to the Pivotal Web Services Cloud, how to configure that, how to make it scalable, and we'll do a short load test to see that it actually responds to difference in load. And then we'll end with the challenges that are faced, and I'm not sure currently being faced by the Mendix R&D team to solve some of the problems to truly become high available. Because we're not completely there yet, we're almost there.
Almost there, yes.
But first, we're going to have a running example throughout our presentation, and I want to introduce you to Haley. Haley is the subject of our running example, and she's going to try to order the latest Lady Gaga album online. But first, let's talk about high availability. High availability, basically, this is one of the definitions we found. It's a characteristic of a system which aims to ensure an agreed level of operational performance for a higher than normal period. I would just like to say you just want to make sure that your service is available at any time. So no matter what happens, like your service must be running, because you want happy customers. You want them to be able to purchase that album with you. So there's a few things that come into play when your application is running. So we're going to start at basically the lowest level, the infrastructure level. We don't run our applications anymore on just my laptop, my personal computer with a single hard disk drive, with a single power source that can fill. We usually run our applications in data centers which are equipped with redundancy. So we have no single source of failure. If one of the power supplies dies, usually there's a backup or a generator that comes into play, so the whole data center as a whole still keeps running. So one of the principles when you're trying to look at high availability is eliminating those single points of failure. And as you know, running software is actually kind of a complex thing, because you not only have network, storage, power, operating system, all kinds of variables basically that can die, that can do unpredicted things. And you're trying to, high availability is all about trying to understand those single points of failure and coming up with something so you can make sure that everything runs smoothly. So let's have a look at our example. Haley's trying to order this album. She's very happy. Our one server is currently running in our data center, which is redundant, so we've done quite a good job. And then disaster happens. This is a photo from Russia a few years back where a meteor actually hit Earth. You don't want that meteor on your data center, because then, obviously, your customers get unhappy because our server is down, the purchase is lost, and unhappy customers. So let's look at another level of abstraction, what we can use to actually make our applications become high available. And as you've heard during the keynote from Derek, Cloud Foundry has been adopted by Mendix as a cloud architecture. And this also brings us at the software level a few things that will help us. And one of them, which we're going to talk about most, is availability zones. So we no longer have just one data center in one geographical area, but we can spread our application and make it run in Amsterdam, in Boston, in Singapore, or even within the Netherlands, within Rotterdam, Amsterdam, and somewhere in Limburg, I guess. So when disaster happens, when a meteor strikes, when a fire happens, or a squirrel eats through one of your power cables, like traffic is automatically routed to a different location that is still running your application. And besides that, Cloud Foundry also takes care of monitoring, recovering, and alerting. So once an instance dies, it's detected by Cloud Foundry and it will automatically bring it back to life again. And it will also monitor its own software that is running. So there we go again. 2 data centers, geographically spread. We have our applications running on multiple locations, and Haley again is trying to buy this album. The one instance got struck by the meteor, and she's automatically routed to a different instance, which is still running, and we end up with a happy customer. Now, Arjan will continue to talk about scalability and how that affects high availability.
Yeah, so now we know all about high availability. Scalability, that allows your application to handle bigger amounts of work or to be able to be easily expanded so that more work can be, or higher demand can be served. You can see on this slide, you can see the well-known Matryoshka dolls. And what you can see is they grow in size, so the worker gets bigger, can handle more work, and they also grow in numbers. And with more numbers, you can divide the load, and you can also do more work. And actually, there are specific terms for these types of scalability, and those are vertical and horizontal scalability. So in the left image, you see vertical, and well, that's quite clear, that's bigger, and in IT terms, that means that you either have more CPU power or you allocate more memory so that you can do more work. And on the other hand, you have horizontal scaling. Horizontal scaling means that you will create more instances, so more servers which can do the load. And you can see that illustrated by the ants, which are in high numbers, and in that way, it's easy for them to carry the load of all the leaves. Let's get back to our running example. In this case, Haley brought some of her friends, and they all want to buy this Lady Gaga album. As you remembered, we had 2 instances, and they were even in different availability zones. But because the load is so much, they cannot handle this anymore, and Haley and her friends get very sad, of course. What we can do now is we can either scale vertically, so we make the instances bigger. That's one way to solve this problem. Or we can scale horizontally. That's the second way. So we create more instances. Well, this all looks nice on a picture, but wouldn't it be great to see these live in action? And that's what Keelan is going to show you now.
So yeah, I tested the Wi-Fi and it should be okay, so fingers crossed. And I think we're going to switch microphones because unfortunately I need to sit down because I need to use my mic and the desk here is just too small, so I'm not going to be able to look at you, but we'll make the best of it. Curious about this. It's yours. There we go. And now I need to duplicate it again. Okay, so we have this very, very simple Mendix application we've just built to demonstrate to you. So I'm not going to explain to you what it does right now because further on in the demo, we're going to deploy to the cloud and that will take some time. So we'll use that time to actually explain what we're doing here. It's actually not that exciting. But to deploy to a Cloud Foundry instance, we can use the Mendix Modeler. We can just go to Run, edit Cloud Foundry configuration. And there, in this case, already my API endpoint, which in this case is Pivotal Web Services, but it could be HP Helium, it could be Bluemix, it could be basically any Cloud Foundry instance that is running, and my username and password. So I'm basically logging in now. The application will see which spaces and organizations I have, So I am a member of a conclusion organization, and I currently have 2 spaces where I can deploy an application. I have a development space and a demo, and we'll be using the demo space for today's demo. So I'm going to create a new application, and I'm going to call it Mendix World 2016. I will just hope that nobody used this before, but we'll see, we'll find out, otherwise we'll just rename it. So there it is. I've just configured an instance in Pivotal Web Services, and now I can go to their console to actually configure it. So this is the Pivotal Web Services console. As you see, I have the conclusion organization and a demo and a development space. Now let's just go to the demo space. Right now, this is just a computing instance. It doesn't really do anything. It doesn't have a database yet. It doesn't have file storage yet. So we need to configure that. And actually, it is quite easy. So in order to have a database connected to this space, I can go to the services, and I can choose from a marketplace of services that are available. You have several here, and we're going to use the Elephant SQL, which, as you, I guess, hope you can read in the back, is a PostgreSQL as a service. So right now, I'm just going to use the free edition because this demo is not going to be that excited. I'm going to select this plan. We're going to give it a name. So let's say Mendix World Data Store. And I'm going to bind it to the application, the Mendix World 2016 application we've just created. And the only thing I need to do is press the add button. Now, like, some communication is going on, some settings are being exchanged, and this is all I need to do to have a database working with this application. So yeah, let's go to the app. We have the database down, but we also need, I think they changed this overnight. We need to have file storage. We're not going to use it, but I'm going to show you how file storage is being used. Arjen will talk about it later in the presentation. But for now, we're going to use Amazon S3 as a bucket to store our files. And what we need to do is to add some environmental variables so the application knows where the bucket is, how to authenticate. So I have this notepad thingy with 3 variables. So this is my access key. Oh, I need to remove the tab that's behind there. So this basically is my username, then a password. And for the ones that can write quickly, you can use my blob storage for the next few hours until I remove it. The bucket I'm going to use, which is the Mendix World bucket. Let's get the D in there. And for now, that's all we need to do. Let's save that. And now we have like a connection to Amazon where we can store files. So yeah, that for now is actually all that's needed for the application to deploy. So let's go ahead to the Mendix Modeler and say run, and run on Cloud Foundry. And this process will actually take a while because, as you're used to, it will generate the MDA, it will upload it to Pivotal, the instance will be started, and a lot of things are going on. So I'm going to show you the log files, if they're still the same. They actually changed this since yesterday. I'm still looking where things are. So I'll get back to this, and you will see that it's trying to download Java. It doesn't have Java yet. It's going to install that. It's going to detect that this is a Mendix 651 application, download the runtime, install it, etc. But let's go back while this is happening in the background, and I'm going to explain you this very difficult application, because this microflow is basically everything it does. I create a random number between 0 and 100,000, and then I iterate from 0 to that random number before I return it. And this is basically just to generate some load, so the service actually won't return an answer within like a few milliseconds. So it actually takes a bit of time for it to compute this number. So let's see what's going on, and hopefully some things are happening. Updated app. So let's see where we are. I think it crashed. That's unexpected. Data hidden. I think I've shown you everything. The database, the file storage, Cloud Foundry, yeah. Well, let's see if we can, I don't think it is running. Mendix World 2016. Sorry? Yeah, good suggestion. Well, I would say it's not a great demo when everything goes perfect. So, but yeah, thanks for the help. It seems like it's running now. So let's see if we can open up the app. I just had this. Oh, there it is. So the app is running. We have a database, file storage. I can log in with my Mendix admin account if that still works. And I should show you that like the application doesn't do anything. It produces random numbers. So let me hit the input. I've prepared a web service so I can call this application to get a random number. And I'm going to show you in SOAP UI. It might be small. I'm going to open that and say that this is one of my previous attempts. There we go. That we can call a SOAP service. We should be getting back. Oh, yep, thanks. There we go. So 95,000, 32,000. Well, I guess you get the point. We get back random numbers. So let me save this project, and then I'm going to switch to load the UI to generate some loads so I can show you some more things. But before that, we need to configure a few things more, because now we just have a simple application, but it's not configured to run in clustered mode. And actually, that's quite complicated to do. Here you see my Mendix admin password, which is also very complicated. Basically, the only thing we need to do is tell the environment that clustered enabled is set to true, which is anything, like now the Mendix instance knows it can run in clustered mode. So let's go ahead and also add one more service, which is the autoscaling service. I'm going for the gold pack this time because it detects changes faster. Like the bronze pack detects it every 5 minutes and the gold one every 30 seconds, and we don't want to wait 5 minutes. So let's go for gold and call it the Mendix World App Autoscaler and bind it to our application. And yeah, one more thing in the app, which is still running. We need to configure the autoscaler. We need to turn it on. And I have an experimental demo account, and I have 2 gigabytes of RAM that I can use. So for this demo, I'm going to say that we run a minimum of 1 instance, which isn't high available because if that data center dies, the application is gone, but I guess you get the point. And since I don't have more than 2 gigs and the instances use half a gigabyte of memory, I'm going to set 4 as the maximum. And what will happen is when the load gets above 80% on the CPU, it will automatically detect that and start to add more instances. So let's go ahead and save that, and we'll go back and restart our application just to be sure that the configuration is updated. And then I'm going over to load UI. While this is starting, I can explain you what I'm going to do. I think it crashed. Load UI. Yeah, restart it. Sorry about this. Let's just kill that. I don't have any other ones running, right? No. So the point of load UI is that I'm going to basically do a performance test where we'll start off with just 1 request a second to our random number service. And the nice thing is that it has a knot where we can actually like up it on runtime, so we can go in steps of 10 or 20 or whatever. Let's import the project we've just used. I think I need to rebuild it, unfortunately, but Mendix World. Let's open it up. So here I have a fixed rate data generator, which is now set to just one request a second. And once this is running, I need to connect this to the SOAP UI project we've just used. SOAP UI. So let's go ahead. Hope this works. So here you can see we have 3, 4, 5 requests, and what we should be seeing is that in the overview our CPU usage should be going up. Pivotal metrics. So we have now like a little bit of traffic, 5% of CPU usage. Not that much is actually going on, but let's actually add this a bit. Anybody a suggestion? Like somewhere between 0 and I think the maximum is about 70. So, any random numbers between 0 and 60? Anybody? 40? 42. Okay, let's go for 42. So I can add like some statistics so you can actually see that time taken. I had this all prepared. Response size sent. There we go. That's not the one I was looking for. I think it's no. Anyway. What we should be seeing is that the CPU usage is going to go up. Let's see if everything still goes as planned. I think maybe my traffic is being throttled somehow. At least it's doing something. But I'm not quite sure if we can actually get there. Oh yeah, there we go. Well, so far for the demo. It's going to send me emails that they're trying to scale, probably. Yeah, I would say I can show one of the first people in the row that this is an email from Pivotal that they scaled my app from 1 to 2, but then the second crashed. So this is hey, there we go. While Preparedness, this went a lot faster, but I think for now I'll just, something is wrong, so they changed something. Basically what I wanted to show you is that once we add the traffic, more instances will be added, which is happening somehow, but I think it was going to take a little bit longer than I planned. And when we stop it, it will automatically detect that there's no traffic to handle anymore, and it will decrease those instances. So this basically is a demo of, okay. There we go. I still saved the demo. Why it says it's crashed, probably what they should be saying is that it's initiated or starting, but I'll contact the guys of Pivotal. They're here, right? I'll walk by them after the presentation. But anyway, yeah, I don't want to take more time of the demo. I think I've shown you what I wanted to show, so let's switch to Arjan with the last part of her presentation. Yeah, so what do you want to say? Sorry, what? Yeah, it didn't get saved.
You didn't save it?
I didn't. You guys couldn't tell me earlier? I didn't hit the plus sign.
And the save? You didn't save it.
Thanks. So anyway, let's switch to back to Arjan while I get the presentation on the screen now.
Yeah, thanks. As you can see, Pivotal is a very agile company. Overnight, a lot of stuff can change. You can see the interface is really easy to use. Like it's easy to set the autoscaler, and depending on CPU loads, you can either scale up and down your applications. What you could see probably is that this is a really simple app, and it doesn't really have any internal state. And you can imagine that a typical Mendix app will be much more complicated than this. And this requires also that the platform needs to be able to handle this. And there are some challenges we had to resolve in order to do that. And I will now briefly walk by each of these challenges. First one is file storage. Second one is session state. And the third one is that there are certain activities which should be performed by one of the server nodes only. I will go into a bit more detail now for each of those. So let's start with file storage. So in a typical Mendix app, if you upload, say, a picture, there's a request sent to the server, and the server stores it on the local file system. And then when you want to download it again, another request is sent to the server, and it gets it from the local file system and presents it to the user. But you can imagine if you have multiple instances, then the first request, the upload, can go to one instance, but the download can go to another instance, and that second instance cannot reach the local file system of the first one. So we needed to change that. So what we did is we built two connectors. So we got rid of the local file system, built a connector for Amazon S3, and one for Azure Blob Storage. And by doing that, there's a central place where the files are stored. Every node can access it, and it's also easy to have like multiple storages in different availability zones. So you also have your redundancy resolved in that way. So with that, we fixed the file storage. Up to the next one, session state. With session state, I mean both the session itself. So if you sign into a Mendix application, you get a session, a user session. And there are some characteristics such as a session ID, which user it's associated with, some security-related aspects such as CSRF tokens. And with every request, every server needs to know of these aspects. And also the data you create and manipulate in your application also needs to be known by the server. Let's see why that's important. We're back with Haley, and Haley still wants to buy this Lady Gaga album. So she sends a request, and it ends up in instance number 1. But for some reason, instance number 1 dies. Maybe doesn't like Lady Gaga. It's gone. And Haley just put that album in the cart, and she wants to proceed to the checkout. So she sends a request again, but it cannot go to the instance which died, so it goes to the other one. But that instance doesn't know anything about the Lady Gaga album being bought, because that was all in memory of the first server. So she gets sad, of course. So this begs the question, where should the session state go? We cannot have it in memory of the server anymore. Earlier there was a logical thing to do because the memory is really fast, but that doesn't hold anymore now. So what we could do, that was a bit too quick, we can store it in the Mendix database. There's already all the other data, and we could store these changes as well. But that can become quite slow because you have to persist every change. Everything has to go to the database. So that will hamper your performance. Another option would be to store it in Redis. Redis is a NoSQL database, and it has quite efficient data structures. And also it doesn't have a transaction system such as a relational database. So the performance is much higher. You can get data into it much quicker and also retrieve it faster. And that works pretty well for most applications. Only applications which use a lot of what we call non-persistent objects. So those are objects which are not persistent into the database and which have a maximum lifetime of a session. If you would create a lot of those still have to be held in the server memory because they have to be sent with a request to the client. So you have a chance of blowing up your server if you have an application which creates a lot of those. So that's why we decided to go in a different direction, and that's to store the state in the web client. And the advantage of a web client is the web client is always one session. That's the user who signed in to the application. So that means that the amount of memory it uses is much less than it would be for the server, which has to keep the objects for all sessions in memory. So by using the web client, the server cannot crash anymore unless you have so many objects in your web client that it would still crash. But then you have to change something in your application. So what did we need to do to be able to move the state to the client? First, of course, we have to remember the objects in the client. They used to be in the server, but if the server does a request and gets something back, after that it forgot all about the objects. So the client needs to know of the object, and it means that if you file a request to the server, it needs to send the full object if it's a changed object or if it's a non-persistent object. So there's a little bit more data which you have to send over the wire, approximately around 10%. But the advantage is that we have way less round trips. Up to now, we had separate requests to send changes to the server and also to retrieve full objects from the server. But because they are both now already known in the web client, this saves us a lot of round trip, a lot of requests. And certainly for networks where you have high latency, this can definitely improve your performance. Third aspect we had to change was the garbage collection. So if you have an object state and you create more and more objects, at some point you won't be using them anymore in your application, and you want to get rid of these objects because otherwise you're still accumulating your state. And this used to happen on the server because the state is on the server, but we moved it to the web client now. And it can even be a bit more efficient now because we're closer to where the objects are actually shown in your page, where they're being used in the widgets. And the fourth thing we had to do was to automatically detect which inputs a microflow needs. Up to now, we would just send IDs to the server and it would fetch all the objects it needs. But because all the objects are in the web client now, we have to calculate this upfront and send everything which is necessary to the server. When we did all this, we're currently in the process of doing that. Then all the states in the client and the server can be truly stateless in that way. Next. Yes, so that solves the session state. Then we have one left, that is to perform activities which should be only performed on one node. An example of this is if you change something in your domain model, let's say you change the name of an entity, this change has to be reflected in the database as well, so the table name needs to be changed. So when you launch the application, the runtime will detect that the database needs to be migrated and the necessary queries are being executed. But if you have multiple instances, you don't want every instance to call this database migration because you can run into concurrency issues there. So only one node should perform this activity. And the same holds for instance, scaled events. If you want to execute a certain scaled event, only one node should do that. For that, we use the cluster leader. And the cluster leader uses the idea that on Cloud Foundry, automatically, the first node which comes up gets ID 0, and our Mendix Cloud Foundry build pack, which is a layer between the runtime and Cloud Foundry, can detect which node this is, and based on that, make sure that that's the node who will execute these activities. So with that last challenge resolved, we have everything in place to have a truly stateless and scalable runtime. And that's great. But I can imagine that you're wondering, when do we get all this? So let's go to the release schedule. So first we saw file storage. The S3 file storage is already available since Mendix 5.16. Recently we also built a connector for Azure, and that's finished, and it will be part of Mendix 6.6, which will be released in this month. Then we have the session state in the web client. We are currently building this, and this will be part of Mendix 7. And finally, the cluster reader, that's already part of the Mendix build pack, so you can already use that. So with this release schedule clear, let's return to Haley one more time. Oh, that was a bit quick.
Just gave it away.
She multiplied. As we saw in the examples at the start of the talk from Amazon, Twitter, and Yahoo, that made it very clear why high availability and scalability is so important. And we also saw how easy it is to scale applications up and down using Cloud Foundry. And finally, we took a peek under the hood of the Mendix Runtime, and we followed its road to become truly stateless, which will be completed in Mendix 7. And with these tools and knowledge in hand, you should have everything in place for your Mendix application to serve any of Haley's requests, even if she brings all of her friends. Thank you for your attention. Any questions? Yes?
So you're saying that there's a node 0 that is the leader.
Mm-hmm.
What happens if node 0 fails?
Then another node will become the node 0. It will then be. That will be handled by Cloud Foundry. Yeah.
What is the
Sorry. Go ahead.
what is the maximum amount of memory a single node can address, a single Mendix instance can address?
Yeah, that really depends on your hardware. It can be as large as you want to be. Yeah, in theory you can do that, but it's probably better to scale it horizontally because that scales much better.
I haven't tested a terabyte.
Yeah.
Let's go over here first.
So how do you manage stuff like scheduled events when you have, let's say, one batch that needs to run in the background? Which node decides to run stuff like scheduled events?
Yeah, so for now that is always the cluster leader. We will be introducing later on, we will be introducing something on a higher level where you can have a scheduler which just looks which node does not have a lot of load and then will automatically push it to that node. But for now it's just the cluster leader.
Let's first do the gentleman over there and then we'll come back to you, sir.
So I just want to understand, moving the state to the client with the leader, does that make the client a lot bigger? That's one question. And the other one is, if the server becomes truly stateless,
Mm-hmm.
I just want to try and figure out how you're going to manage your transactions and your non-persistent entities that you create as part of flows, or lots of microflows, and it's how we manage it.
Yeah, so the first question, if I understood correctly, is so we're moving the state to the client, and does it not become more complicated or bigger? So we have to write a bit more code, that's true. But also there are parts which become much simpler, such as that we can cut out some requests. And also the client did some quite complicated calculations to send which stuff to garbage collect for the server. And we can also remove that because we know that a client side now. So actually we can also throw away quite some code. Yeah. And secondly,
So if you move all the state, well, let me ask the question this way. Is there something that a Mendix developer has to keep in mind when he's writing microflows and thinking about state with non-persistent entities?
Well, the only thing which can really go wrong is if you have the state in the client, if you would have like a request which creates like millions of objects, non-persistent objects, and you would all send them to the web client. Then, of course, your browser memory will explode. So that's probably not a good thing to do. But yeah, you probably also don't want to show 1 million objects in your web client. So probably that won't be a problem, but if you associate these objects with another object you are showing, and you can reach that, that might be a problem. So that's why we are looking into to disallow to walk from a PE to an MPE. You can already not have associations that way, but you can walk that way, and by disallowing that, the state can be kept much smaller. Yeah.
So we already promised the very last question, sorry. Sorry, there you go.
Will we be able to configure this through the standard Mendix portal?
That's a good question. The question is whether, like we've just seen in the demo, that we used Pivotal Web Services to configure this all, and whether that feature also becomes available in the Mendix Cloud portal.
Well, the Pivotal deployment and the cloud deployment are now two separate things. And like in the backend, that could be, for instance, Pivotal or Amazon or something else. But the interface is unique for the cloud portal is the Mendix interface, and the Pivotal interface has its own. But you can choose for yourself what you would like to use. You're totally free in the.
So we won't be able to, we can't monitor the state of the app or the apps through the standard Mendix portal or anything like that?
There are some graphs now which where you currently for the server-side state you can you have some graphs which count the number of objects in the state. When we are moving it to the client, that will all be in the client, so we cannot reach that from, for instance, Pivotal. But we will offer an option where you, with a shortcut key, you can look if you are in the web client, where you can look where all the objects are in the state, so that if you would experience some problems, you can debug it to see where everything goes.
Cool, thank you all. If you have any more questions, feel free to talk to Arjan or visit me at the conclusion booth. Thanks for attending, and yeah, we'd like to see you again at next Mendix World.